previous lesson, we are going to continue our unit 2, sound and light. Let's start our new lesson.
Continue our unit lesson 3, refraction and refraction of light. Why we can see an inverted image of a building on the surface of water? From the previous lesson, you studied that light travels in straight lines and doesn't pass through dark objects. So the result is the formation of shadow. In this lesson, we will talk about two basic concepts of light, which are light reflection, light refraction. The first one, light reflection. Sometimes in our daily life, we can observe the formation of inverted image of trees and buildings on the surface of water or in the road when rain falls. That's because when light meets a reflecting surface, it returns back again, and this is known light reflection. So, light reflection is a rebounding or returning back of light waves in the same medium when it strikes a reflecting surface. Light reflection is classified according to the nature of the reflecting surface into two types: regular or uniform reflection, irregular or uniform reflection. Regular reflection is the reflection of light rays when they meet, fall on a smooth or glistening reflecting surface, where the incident light rays are reflecting in one direction. Irregular reflection is the reflection of light rays when they meet or fall on a reflecting surface, where the incident light rays are reflected in different directions. Law of light reflection. To know the law of light reflection, we should know some basic concepts that are used in these laws. The first one, the incident light ray, is the light ray that falls on the reflecting surface. The reflected light ray is the light ray that returns back from the reflecting surface. Angle of incidence is the angle between the incident light ray and the normal. Angle of reflection is the angle between the reflecting light ray and the normal. Let's move on the second point of this lesson, light refraction. Light reflection is the change of light path when it travels from a transparent medium to another transparent medium or different optical density. Optical density of the medium is the ability of transparent medium to refract light. Let's see this video.
Of light, or the bending of light. And you can see in this picture here there's a lot of bent light going on. And so what really happens, if we look at a laser light, as it moves through the air, you can see there's no refraction of light or bending of light. But once it hits this glass surface, there's a bending of the light. Now there's a little bit of reflection off the surface, but there's a lot of refraction or bent transmitted light like this. And the reason it's bending is because we're changing the speed at which it's moving through the medium. And I'll give you an analogy that's going to help you in a little bit. What would happen if we go straight into the medium? It's just going to go straight through. And so if you look on the glass to the left, the light that's coming straight through the middle where the surface is flat, it's not being refracted at all. It's only on that bent surface where we see that major refraction. And so when light moves from one medium to another, it can be reflected, absorbed, or transmitted.
Light refraction. There are some facts about light refraction. Number one, when a light ray travels from a transparent medium of lower optical density like air or water to another of the higher optical density like glass, it refracts near the normal, like figure 1. So the angle of incidence is greater than the angle of refraction. Number 2, when a light ray travels from a transparent medium of a higher optical density like glass to another of lower optical density like air, it refracts far from the normal, like figure 2. So the angle of incidence is less than the angle of refraction. Number 3 and the last one, When a light ray falls perpendicular to the interface between two different transparent media, it passes to the other medium without refraction. Angle of incidence equals 0. Absolute refractive index of a medium is the ratio between the velocity of light through air to the velocity of light through another transparent medium. So, absolute refractive index of a medium equals velocity of light through air over velocity of light through the medium. So if the refractive index of a medium is high, this means that its optical density is high and vice versa. So we give reasons the absolute refractive index of any transparent medium is always greater than 1, because the velocity of light through air is always greater than through any another transparent medium. Let's solve this problem. Calculate the velocity of light through glass given that the velocity of light through air equals 3 times 10 over 8 meter per second and the absolute refractive index of glass is 1.5. First, we should make this law. Absolute refractive index of a medium equals velocity of light through air over velocity of light through the medium. Do not forget that the optical density of different mediums is follow glass bigger than water, bigger than air. So, absolute refractive index of a medium equals 3 times 10 over 8 over 1.5 equal 2 times 10 over 8 meter per second. The last point of this lesson, natural phenomena related to refraction and refraction of light. Number 1, apparent shapes of object. Number 2, apparent position of object. Number 3, mirage. Mirage phenomenon occurs due to the reflection and refraction of light in air layers, which differ in the degree of temperature. So, mirage is a natural phenomenon that takes place on the desert, where objects on the roadside seem as if they have inverted image on a wet area. We are finished our unit 2, sound and light. Thanks for watching. See you next unit, inshallah. And if you have any question, keep in touch with me in WhatsApp. Goodbye.